Right, where we left off last week was very frustrating. Right, so where we left last week was very frustrating because I was trying to import the character set from the VIC-20 into the C64 and the ship was not coming out as we would have expected it. So we was so you need to start streaming so you can do some bots too. Oh, it's good fun. It's good fun. It's good to have a JavaScript expert as well because I was no JS in it, so I thought that it was the same, but it's not apparently. Anyway, so last week I ended with my head in my hands because of the character set, and the character set was because the Myriad, the VIC-20 character set, when you put it onto the 64 into multicolored mode, didn't come out as we would expect, right? So if I fire up Myriad, so let's fire up Myriad. There we go. No mention of playing Arcadia. Yeah, I love that game, but it's rock hard. It's absolute rock hard. So when we fire up Myriad, yeah, that is the ship. And if you remember, when we was doing it, we was getting yellow here, purple there, and all that. And that is because the multicolor mode in the VIC-20 is different than the Commodore 64. And I'll explain what I mean. So I wrote a little thing called information. Here we go. So this is the multicolor mode between the computers that we're going to be messing around with. So we have 4 colors. We have that one, that one, that one, and that one. Yeah. Well, now I completely understand. So I've done a matrix here. So the first one, 0, 0, is the background for the VIC-20, the C64 and 128, and the C16. Yeah. Then this is where it starts deviating because the VIC-20 uses the border color as one of the multicolors, as the 64's got background 1 and the C16's got background 1 apparently. This is where it completely throws a spanner because 10 is the character color, but for the C64 it's the background color, and the C16 is the background color, and then the last one for the VIC-20 is the auxiliary color, but for the C64 it's the character color, and same with the C16. So to overcome this problem, I went back to basics. And a favourite little program of mine called CPS has come to the rescue once again. So what I did is I created a project for the VIC-20 and I just imported the character set straight into it. So here's the character set for the VIC-20. Yeah. So on the multicolored, so what I did is created a scratch pad lot. Yeah. And these are all the bad guys. Yeah. Now at the bottom, these are the bad guys in high res mode. They're not multicolored. But if I turn multicolor on, then this is what they look like. Yeah. So these are all the bad guys. So as you can see, we've got border color, character color, and auxiliary color. So what I had to do was create a C64 project with the VIC-20 Myriad character setting. And as you can see, in multicolour mode, it's background, background 1, background 2, character colour. And if I switch multicolour on, I have actually gone through every character and swapped the green for yellow. So basically swapped 1 1 to 1 0, and 1 0s are now 1 1s. So green becomes yellow and yellow has become green. And I've done it for all the characters in the character set that were multicolour, and I did that this weekend. Then I exported it as a bin file. Yeah. Now, yeah, it took me a while. So, and also the C16 is the same as the 64. Now the colours will look a bit wishy-washy because they've got, you know, proper colours. So if I go to, let's just do that and do that and do that. Yeah. Yes, save that. Go back into it because there's a bug in this version, which I've told AJ about. See, the colours are better, but they're still the same philosophy as the 64. So we can use the C64 character set on the C16, but we can't use the VIC-20 character set because it doesn't look right. So, after I'd done all that, and, you know, CPS came to the rescue. It was a lot easier doing it in CPS than Charpad. I had big problems with Charpad. But CPS came to the rescue. So, I have now 2 character sets. Right? So, I have the C64 character set, which is here. So, I've left the blanks in, because just in case we want to add more bad guys once we've once we've recoded it. So we've got plenty of space to add more bad guys or add more animation, yeah? Or add more animation. And I've also got the VIC-20 character set. Yeah? So, and they are configured properly. Alright? So I did a little bit of playing at the weekend. So this is the C64 version. I did a bit of playing at the weekend. And so if I run this, there you go. Now I don't know if you can see it, but can you see that the shield is on? Yeah. And it's flickering like it does in Myriad. Yeah. So I've put in the routine that does the multicolour toggling, yeah, as well. So what I want to do in this stream is I want to get the ship to start moving around the screen, yeah. So we've already got the shields. So if I ram that out and rerun it, we should have the flames at the bottom. There you go. So I've already put in the shield code, yeah, where it puts the shield, but that's all I've done except for the IRQ. And the way the multicolour mode's running is I've got an IRQ file. Oh, it's there. So what I've done is I've got a setup that points to the new IRQ, and then here we're storing away the CPU status, storing away the registers, we're loading the background colour, XORing it with 3 and storing it back, and basically that's going to switch between purple and yellow, because that's what it does in the VIC-20 version, but it's done in a more long-winded way. So if we go to the VIC-20 version and search for IRQ, here we go. So it's doing it in a different way. Right here, it's doing it here, look. So he's loading the register for the multicolour mode. He's comparing it with 4, which is purple, because remember the multicolour part of it is the top nibble. The bottom nibble is the volume control. He's comparing it with 4F, and if it's not 4F, he's setting it to 4F. But if it's not 4F, then he sets it to 7F, which is yellow. Now you don't have to do it that way. You can use the XOR, yeah, and that's what I've done. In here is just basically doing exactly the same thing, and then we acknowledge the IRQ, and then we reinstate the registers, and then reinstate the CPU status. So nothing gets changed when the IRQ is running, yeah. And all what I've done on top of that was I just added this. So this is the ship. So this is where we draw the 6 plus 2, which is the 2 at bottom is the flames, 6 is the ship. But I've got a test in here that says when the shield is active, it does this and draws the shield around the ship. Right? And it's exactly the same code as what Steve wrote in the VIC-20 game. So basically I've kept to his philosophy, and I'm trying to keep to his philosophy of what he'd coded, but we're trying to optimize as much as we can and try and tidy up as much as we can. But I also want to be able to do this for the C64 and VIC. So what we need to do is to make sure that we've got the dimensions right. So the first things that I wanted to do was in the dimensions thing, we need to set up another thing called screen, and this is where we're going to put all the dimensions. Yeah. So label number of rows equals 25 for the C64. Number of cols equals 40. So here we're going to be putting in these ifs, yeah. So if C64 or C128 or Mega 65, because I think we're gonna have a crack at doing that. Else if VIC-20 is going to be different. Now we worked out the VIC, we was going to make it bigger, weren't we? So where's that bit of paper that I put down? Where is it? It's around here somewhere. It's around here somewhere. Too many bits of paper. Oh, did I? Oh, I wrote it down, didn't I? Oh, it's down here, look, to the bottom. Right, so we're 27 rows, and we are 33 columns for the VIC-20. So it's almost going to be the same size as a C64 screen when we've finished with it. And now what we need to do is we need to then work out all the boundaries, yeah? All the boundaries. So the bottom row is, so if we fire up Myriad, if we fire it up and we'll have a look. Right, F1, we'll get it to play and then we'll pause it. Right, so we are going to make the screen far bigger. Yeah, 27 by 33 columns. But here is where the scoring's going to go, which is going to be down here. So even though we've got 27 rows, our bottom of the screen, no Commander 16. Well, that's going to be basically like C64, really, isn't it? And to be honest, mate, the amount of money they're asking for the X16, it's dubious that I'm going to get one now. Because I was thinking of getting one, but not the amount of money they're asking for. Anyway, so the bottom of the screen, so the bottom of the play area is going to be 1, 2 away from the bottom of the screen, right? So if we go back to ours, so the yeah, no mate, it's not going to be a sensible price. Right, so the bottom row is going to be equal to the number of rows minus 2, yeah? So let's create a new, so playable area. So we're going to create a playable area where the top row is always going to be 1. Always. It's not going to be any. The bottom row of the playable area is going to be the number of rows minus 2, because the bottom row is going to be where the score is, and then we've got that solid, we've got the solid line above it here. So that's the bottom of the playable area, yeah? So the leftmost column is going to be 1, and the rightmost column is going to be number of columns. Right? Now, the bottom of the screen, I don't know what that was. Bottom of the screen. I still think that's the bottom of that. So we can get rid of that. So bottom row is that. Then we've got some ship dimensions, right? So ship. So we've got playable area. Let's move that over. So ship. Yes, we'll be doing a C16 version. But that's, I mean, that could be up here, isn't it? C16, because it's the same dimensions. Did I call it a C16? Yeah, I did. I did. I called it a C16 in Petsky Matrix, didn't I? Oh, I can't remember. Let's load it up. Have I got it in there? Ooh, is that it? No, that's Scramble. Laser Zone. Petsky Matrix, here we go. So let me open folder. Let's go back a level. There we go. Select folder. So what did I pick? Right, so VIC-20, PET, Mega 65, C128, C16. Yep. So there'll be a C16 version as well. Yeah. And my bot, is my bot running? Yeah, it's running. Okay. Right. So, ship. So we call what? So the ship extremes. There we go. Extremes. So leftmost column equals 1. Rightmost column equals, right, so it's going to be number of coals, and because have we got it running? Yeah, we got it running. So the ship coordinate is here, yeah. So we've got 1, 2, and I think we have one space to that side. I think. Hang on. Yeah. Oh, that's 2, isn't it? No, it's 1. So we've got 1 space to that side and 1 space to that side. Right, so let's pause that. So leftmost column is going to be 2, and the rightmost column is going to be 40 minus 1 minus the 2 for the ship. So it's going to be minus 3. Right, so the rightmost column, topmost row is going to equal, and I don't think we get to the top, do we? There we go. Let's get a bit of space. Yeah, so that's definitely one row from the top. And from the bottom, it's 1 row from the bottom. Right, so let's put them in. So the topmost row is going to be row 2, and the bottom most row is going to be number of columns. No, it isn't. It's going to be the playable area is the bottom row minus 1. Yeah. So there are going to be the extreme of the ship. So where the ship can go. So right, let's think about this. So we've I need to put an end if there, don't I? Right. What about the height of the ship to its position? Well, the position of the ship, right? The coordinate of the ship is this cell here. That's why we're good. I see what you're getting now. I see what you're getting. So the ship is 4 high. I see where you're getting. So the ship is 4 chars high. So that needs to be 5. Good spot. Good spot. Good spot, mate. Well done. There you go. I typed it in right now. We've worked out the playable area. Now the playable area is where all the bad guys can move about, yeah? And now we've worked out the extremes of the ship, where it can go around, yeah? So we need to put in here that, and we need to do, it's not the number of columns, it's that, because we're still within the confines of the playable area, yeah? So we're still in the confines of the playable area. So I think what we need to do then is to say leftmost column equals playable area dot leftmost column plus 1, and topmost row should be playable. Oh, no. Should be that dot top row plus 1. So we're trying to keep everything linked up. So when we choose by our directives what machine we're going to be assembling on, it knows what the dimensions of the screen are, and then we work out everything after that. So here we're going to have to put in screen that, and screen that. So that should then work out the playable area from our screen and the ship extremes from the playable area, and then we'll have another dimension in here. So we don't need this. We don't need this bottom row now. So Mega 65. Oh, we put pet in there as well, didn't we? Because we're always going to be using a 40 column pet, so we don't need to do that. But I need to copy that, don't I? Put it in there so we know how to set it up, so we can get rid of that. And so what we need to do now is to have scoring row, which is equal to the screen dot bottom number of columns, sorry. Number of columns, number of rows. So the scoring row will always be the bottom row. It should always be the bottom row, no matter what. It should always be the bottom row. Right, so I've set up the colours for the C64. I'll also set up the colours once I've worked them out for the Vic. And the colours will be different for the C16. So what we're going to try and do is we're going to try and implement the control system, the control mechanism to move the ship around the screen. Yeah. So we've set it up, and what I'm going to do here is now I'm going to use our newfound dimensions. Where I've just lost them. Where did I put them? Was it machine specific or constants? Ah, here we go, constants. Right, so our newfound dimensions, I'm going to put them here. So, dimensions dot playable area, not playable area, ship extremes dot leftmost column, rightmost column. Rightmost column divided by 2 as a quickie, and bottom row divide by 2 just as a quickie. Get the ship on the screen to start getting used to what they're looking like. Let's see if that works. So it doesn't like it. Bottommost row is not presented, but it is. Dimensions. Oh, hang on. That's why. Divide by 2. Ooh, dimensions rightmost column. Where's that? Where's that? C64. Line 51. Oh, hang on. That's in ship. Line 51. Because I've redone all these constants now. No. Oh, hang on. That could be in this utils. Because, oh, here we go. So, playable, that's got to be playable area. Yes, it is. So we're moving left by 1. That's on the playable area. So we're going to have the same here. On the bottom of, move down by 1 on the bottom of the screen. So it's not bottom of the screen now, is it? It's bottom row. Move right by 1. So that's playable area again. Going up is not a problem because they never go up. The bad guys never go up. They always go down. They go across or down. They never go up. Right. So we should be able to fire this up now. And we should be still okay. There we go. Right. Ship's on the screen. Now, we're going to now do the controls. So there's 2 sets of controls. There's joystick and keyboard. Now we've changed. We're going to use the keyboard matrix, so we can press 2 keys at the same time, and we're going to use the joystick. So we've already got them in here. Yeah, we've already got the joystick. So there's the joystick routine there. So joystick capture. And that puts the end result into there. And then we've got the keyboard capture, which puts the result in here. So what we need to do is we need to run those routines, yeah, and then act on those routines. So let's do the joystick first. So let's create another file called controls, I suppose. Do our standard import everything. Do a namespace. Right. So what we want to do is we're going to run the joystick capture, yeah. So utils dot, oh, we haven't got utils in there, have we? Come on. Come on. There we go. So run the joystick capture. So that's going to capture the joystick. So what we need to do is we need to give it a name as well, don't we? There we go. Right, so joystick capture. I think. Right, we'll get rid of that because I don't need it. I'll leave. I've got. Is that in there? Yeah, that's in there, so I don't need it in this side. Utils. Now I think it's still in the accumulator. It is. So we can test it straight away. So if it's equal to 0, no. If it's not equal to 0, then in fact, we'll do that. So if the joystick comes back and it's 0, it means that we've not had an input from the joystick, yeah? So we'll put at the moment we'll put an RTS in there. But what we really need to do is we need to do a jump to capture keyboard, because if there's no joystick, row 254 constants. Oh dear. Payable area. That means that's not going to work in the utils. That's not going to work in the utils, is it? Right, let's find it in here. There, payable. Is it utils? Yeah, it is. Here we go. So, playable, playable, playable. Freudian slip there. Freudian slip. Well spotted, mate. You're on the ball, aren't you? There you go. You can have another one. Right. So, like I say, evaluate the joystick. If the joystick comes back and nothing's pressed, at the moment we're going to return back out, yeah? But if it is pressed, then we're going to evaluate it. But we're going to... Was it? Oh. Oh, well, in that case... We'll take them back. And we'll add them. There. Oh, he's on the board, look. He's got his first 5 points. So, not a problem. Right, so we'll add this in later, yeah? We're just going to do the joystick at the moment. So we're going to evaluate the joystick. Evaluate joystick. So what we're doing is there are some storage points in here, which is, if I can find them, here. Now, I'm slowly working my way through here. Because I want to make all the variables run after the other, so we don't waste any 0-page things. Yeah, we don't waste any 0 pages, because there were some 0-page locations in when we reverse engineered. There was gaps that we could have used, and I'm going to try and not waste anything. Also, I want to change this as well. We'll get to that. So I'm slowly working my way where I'm going to say, right, there's the joystick, and then the characters is equal to joystick +1, screen type is equal to that, and I'm going to work my way all the way through. So we have got the joystick now, so we need to evaluate what directions, and we've got our ship X and Y here, yeah. So that is the location of where the ship is going, is currently on the screen. So we're going to be affecting that, all right? So what we're going to do is we're going to test. So we're going to test. So we're going to load storage.joystick. It's saying there's 2. Is there actually 2 in there? No, there isn't. I didn't think there was. Nope. Right. So we're going to load this joystick and we're going to compare, we're going to AND it with, where's the constants? Got the joysticks up here somewhere. Right, they are the joysticks for... They are the joysticks from Myriad. So we are looking for them in here, I think. There we go. Right, so we're looking... So first things first, we'll do joystick up. Yeah. So AND it with joystick up, branch if equal to 0 to alright. so we're going to copy that. Do it again. So joystick down. So load it back in. Do joystick down. Then try right. And we're just going to copy this all the way down. Right, so that's right, left, fire. So down. So this is right. Left. Fire. In fact, we'll do this as well. Put it in its own code block. Right, so that's doing right. So this is doing left. And this is doing fire. So really, we shouldn't need to test for fire because that's the only thing that's left. Right? So what? Because we've already eliminated that no button's been pressed, so that would be doing the fire. So first things first. So we're going up. Yeah. So load. Do we load? Do I do it that way, or do I do it a different way? No, we'll load. So we'll load Y with storage ship Y. We will DE Y. Then we'll compare Y with dimensions dot ship extremes dot top. Come on. Ooh, it was too much to ask. Topmost row. So we're going to test for that. Right? Branch if not equal to. And we'll say exit. Because it means that... Oh, no. Branch if not equal to... where are we going to go? Where are we going to go? We need to go here. Store Y. No, store up result. That'll do. That will do. Branch if not equal to there. And here we are going to be doing STY storage dot ship Y. Then if it is equal to that, then we're going to increase Y. So if it is equal to 2, well, I'm now kind of questioning this. Top row is 1. Yeah, it's definitely, so if it's, yeah, okay. Then we're going to leave it. No, we're not. We're going to do LDY hash, and we're going to do ship dimensions. In fact, copy that. That's it. Do the compare before the decrease. I suppose. Hey, buddy. What's up? What's up, mate? Hey? Oi. Say hello to the camera. Yeah, okay. Yes, we will. Let's implement that. Hey, mate. What's up? Hang on, let me put the camera down so they can see you. There you go. What's up? Hey? What are you here scratching? Hey? Say hello to everyone. Hey? I know, mate. Okay, I'll lift it up for you. Yeah? Oh. Yeah, there. Say hello. Code Inspector. Yes, he is. You're the Code Inspector. Yeah? Come back here. Oh dear. Yeah. The Code Inspector is leaving the building. Okay, let's try that. Let's see. Okay, so you are saying do the compare before the decrease. Okay, so let's do that. So we do the compare. If it's not equal... Oh, if it's equal this time, isn't it? If it's equal, we don't need to do the store, do we? We can go straight here. If it's not equal to the top row, dy, and then store it. So that let's just work that out. So to load y, compare it with the top row. If it's the top row, we jump down and do the test the down. If it's not equal to the top row, dy, store it. Yeah, okay. I like that. I like that, mate. I like that. So we'll repeat this all the way down. So, oh, I forgot those two, didn't I? So ship going down. So we are testing now bottommost row. You get rewarded for the art. You get rewarded for the ideas. Get rewarded for the ideas. So we load y, compare it with the bottom row. If it's equal, we move on to the next one. If it's not equal, then we are going to increase y, and then store it back into y. So that's going down. So we do the same with the other two. So let's just do this here. So this is going, so we are, oh, I need to change up, down, I need to change that, right, and that is left. And we don't worry about fire. Right, so, okay, so we've done up, down, so this is going left. So we're going to use the X register. We're going to load X, ship X, compare with, so we are going, well, I mean, when we're in the this routing's self-contained, yeah, so we're not going to be relying that registers are kept. Yeah, I suppose. Let's finish this stuff then. So we are going left. So leftmost column. We are. Oh no, hang on. This is right, isn't it? Test right. We're going right. So it's that one. Load the ship X. Is it at the right column? Yes, it is. Right. So If it's not, do that. Right, left, right. So we're now on left. Do that. Oh, forgot that. So this is leftmost column. Da 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 da. And we are on fire. DEY, store it. It probably only saves 2 bytes, but I was always about minimizing code. Yes, that is true. So now joystick capture. I'm not too sure if joystick capture destroys the registers. So let's just check. So it uses A there. Oh, right. So it destroys Y in Vic mode, and it destroys X in C16 mode. So we can't preload the registers here, but we can load them here. We can load them here. So if we do LDY ship dot do that, and LDX finish where you are, mate. Can look at it after if you want. Yeah, we'll rem them out because that's we'll put that in there so we can come back to it, yeah? We'll come back to it. Now, I'm not going to do anything on fire at the moment, so we're going to put an RTS there. So what it does, it's going to evaluate the joystick, it's going to affect the where the ship is, and so we need to move the ship, yeah? So we need to move the ship. So what we can do is we're not going to do the loop now here. We are going to start the beginnings of the game loop. Yeah? So start the beginnings of the game loop. Why are you... Oh, I'm going to say. So, JSR. Now we need to include our controls. Oh, you're having a troublesome time today, aren't you? Come on. Can't you find it? Oh, I was going to say. So I'll include controls. And so here we are going to go to controls dot capture control. So we should be able to move the ship around the screen. So let's find out. So there's the ship. Wow. I think it's a bit too fast. I think it's a bit too fast. Right, we need to put the raster in. Hang on. Let's put the raster in. Let's try and give us some chance to control this thing. I think I've got the routine in here somewhere. Wait for raster line. There we go. Might slow it down a little bit, but I'm not too sure. But I'll try and be as dainty as possible. Right. That is going the wrong way. Oh. Right, that's going up and down, right? That's doing it right. But left and right is not. So what's going on with left and right? Ooh, look at this. Copy and paste error. Oh, and it's doing it in Y as well. Right, okay, let's try this again. So we're now linked to the raster now. So we should have a little bit more movement. I mean, that is quick enough, that is. That is quick enough to get around the screen. I don't think we need to worry about that speed. Right, so what we need to do now is we need to clear out. We need to clear out where it is. Yeah? So, but we need a way to flag. We need a way to flag. Right. I'll show you what I mean. I'll show you what I mean. Right. Yeah, I was just thinking about the original code. All right, Fairlane. We'll see you later. Yeah. Now in the original code, he had this thing called Steve had this thing called ship redraw ship, I think it was. He had a flag to draw the ship again. Where is it? Let's go into the original code. Oh, that's game over. Go back. We need to go to the top. Right. So here's his game loop here. So he's got this flag called ship redraw flag. Now I've copied everything across. So there it must be in here somewhere. There it is. Where he's redrawing, where he flags up when you need to redraw the ship. But what we need to do is we need to clear out the ship. So I've got a draw ship and a draw clear ship. So we need to do this. So after we've done the capture control, well, before we do the capture control, we'll do a JSR ship.clear ship. So that clears the ship off the screen, do the capture control, and then redraw it. So let's see what that app works. See if that sorts us out. There we go. Right, that's checking all the extremes. So that bottom's right, but the top's wrong. We need to be able to go up one more. We need to be able to go up one more. So, so the top one is just basically that. Right, let's try that again. There we go, that's it. So we've got, ooh, left hand. We need to go one more cross. So we'll do the same with that left hand. There we go. Right, that seems to be okay there. So let's, where are we? Let's turn the shield on. Let's see what happens when we do the shield. There we go. Sorted. Nice. Now, the problem we've got there now is that we are clearing the ship out and redrawing it on every cycle. So, what we need to do is we need to be able to clear the ship and draw the ship we need to be able to flag that the ship has been is moved. Now the way Steve had done it before was he drew the ship no matter what. He drew the ship, yeah, and so in there he just draws the ship, yeah, but the clear ship, let's see, clear ship, yeah, clear ship graphics happens when so right, okay, so he draws the ship and he only clears the ship when it's been told to redraw it. And I'm wondering if this is just because of the shield. Let's find out where this redraw flag is done. So that's the initializer. That's the game loop. That's the, oh, okay. That's the wave loop, game loop, and then there's one there. What's that? Oh, that's on the IRQ. Okay, so why is that on the IRQ? So he's asking it to be redrawn again. Let's have a look. So decrease the shield timer. If it's not equal to 0, bypass it. Load the shield. If it's equal to 0, if it's equal to 0, bypass it. If it's not equal to 0, that means the shield's been activated. Okay, that's what he's doing. So he's using the redraw for when the shield is activated. So this runs all. So he's actually clearing the ship, redrawing the ship every cycle. So we're doing the same thing. So let's. So we're doing the same thing. Let me put one of these things on. Right. So ink DO20. I want to see how much juice we're taking up. See how much juice we're taking up. Really? We're taking all that up? Are we? Really? Right. Okay, we need that's a lot of juice that's taking up there. Right, so we need a way to specify whether we clear the ship or not. So in the capture controls, I think we need to do it in here. So LDA hash off. Right, so that's turning the redraw flag off, and we'll only turn that back on when we do a move. Yeah. So off is 0. So what's on? I've forgotten what on is. Hang on. What did I set on to be? Uh, 1 to 8 bit 1 to 8. So I think that should be. Well, we'll change that to 255. That'll be easy enough done. But no, go back. If we've modified it, then we have to do that and store it in there. So any modification, we're going to say that the ship needs to be redrawn. Yeah, but by default it'll be switched off. So what we can do then is here is to say, you know, if LDA that and branch if equal do that. Do the capture, and we do the same thing here as well. Bypass draw ship. Oops. Right. What are you complaining about? I'm going to say. Right, let's see how much juice it's taking up now. It still says it's taking a lot of juice up. That can't be. Whoa. Oh. Okay. That is taking a lot of juice up, that is. Let's put that on C60 debugger. Let's find out what's going on there. Right, let's pause it. Come on, pause. I need to find where our code is. Right, where's our... Right, here we go. So, ship. Oh, it's putting... Right, it's putting all the labels. It's not making them 0 page. Why is that? I've had to specify the 0 pages. Well, that could be one reason. Right, 86. That's what we're looking for. So 86 is there. Right, F10. That is being overwritten. That has been over. That means the ROM's using that for some reason. What's 86? Hang on, let's find out what 86 is. But it can't be. It's not. It's. Oh, it is because. Yeah, it is 86, isn't it? Where's the mapping? Where's mapping? What's 86? The random seed value. Well, that's basic. It shouldn't be running that. Oh, hang on. That's 8B, isn't it? Oh, 86 is in the... Oh, right, okay. Bet that's been refreshed. It's definitely been read. Are we actually storing 0 in there? Oh, let's put a breakpoint in. Let's put a breakpoint in controls. Let's find out if we're actually setting it. Well, the breakpoint isn't being triggered. Now it is. Now it is. I think I know what the problem is. Need to put it there. Because what's happening is we was going into it and it was only resetting it once we pressed a key. So now there we go. But now it's clearing it. Because the last thing we do is clear it. So we've got to draw the ship all the time. So we have to draw the ship all the time. But we don't have to... Let's see. No. It takes a lot of juice up, doesn't it, to draw the ship? Maybe we're gonna have to rethink how we draw the ship. Let's just ignore that for the moment. Let's see what we can do with a ship routine. Where is it? Right, so we load the ship in. Place the character on the screen, then load, increase the... I wonder if we need to do these. Work out location. That's location, because that's just increasing X. Work out location. Draw shield, let's see, increase, so that's okay. Right, location. Work out location. We're increasing X again, location, because we don't need to work out Y. We're changing Y. Yeah, you're okay. What are you ever involved? Changing Y, so we need to rework it. Changing Y again. We need to rework it. We need to rework it. We need to rework it. So these are all Y, so they're okay. Right, clear screen cell. Right, where's that? Clear screen cell. Was that in utils? Yes. Clear screen cell. Come on. Choice door. Utils clear screen cell. Capture. Click. All right. So we're evaluating. We'll have two of these then. So for the ones where we increase X, we'll do location. Increase Y, we've got to rework it. Let's do some optimization here. Work it out. Location. Work out what. Right, that should reduce our time, hopefully. There we go. Save some CPU time. And have we broken it? Well, it seems to be okay. Right, let's turn the shield off. Oh, with the shield on, it's a lot more CPU intensive, isn't it? Oh, I like it. We can go diagonally. Oh, nice. Nice. Nice, we can go diagonally. Right. Okay, so that's the joystick. So now we have got to do the keyboard. So what's the typical keyboard? What's the typical keyboard controls? What's the typical keyboard controls? Is it WASD? Is that what it is? WASD. So I presume W is up, D is right, A is left, and S is down, yeah? Is that it? Is that how it works? Right, so let's work them out. So where's the mapping? So we need to work out the mapping for it, because now we're using the keyboard matrix. There we go. This is the fella. QAOP. QAOP? Are you sure it was OP? Or was it QAOK? Yeah, we'll do it the modern way. So right, so here we go. OP's left. Oh, OP's left. Oh, QA's up and down. OP's left, right. Got ya. Oh, okay. But we'll do the WASD, and then we'll see how difficult it is to implement two different strategies. Yeah. So W on that grid. Right. Let's zoom in a bit so you guys can see it. Zoom out one. Right. So we are reading. So this is bit 7, bit 1. Well, this is where we are, where we can get into advanced stuff. So W, where's W? W is on bit 1. So that's DCOO bit 1. That's W. And it's on bit 1 DC. Right. Oh, I've got to write this down. Right. DCOO is 1. DC01 is 1 for W. So what I'm saying is bit 1 here. W is down here. So it's on bit 1 for DC1 and bit 1 for DCOO. Right, so A is next to it. So that's bit 1. So A is DC01 equals 1 and DC01, sorry, equals bit 2. But DCOO is bit 1, still here. Right. S, where's S? Oh, still on bit 1. Oh, we're doing all right on here. DCOO is still bit 1. And so it's bit 5 on DCOO. DC01 is 5 for S. And D, where's D? Oh, trust it to be a different one. Right. DCOO is bit 2. DC01 is bit 2. Now, fire. What we're going to use for fire. What we're going to use for fire. I suppose space is going to be... Yeah, space is going to be the shield though, isn't it? Space is going to be the shield. So space is the shield. And that is where's space. Right, so bit 7. DCOO equals 7. DCO1 equals 4. Left shift. So was space left shift. Okay. So that's shield, and fire is left shift, which is DCOO is bit 1 and DC01 is bit 7. Right, okay, let's find the Vic book. Well, we'll put these in. We'll put these in the thing first. So this is going to be interesting. I can't remember what I read. Where's the keyboard routine? Can't remember what I read. Yeah, right. So we are CIA PR, right. Right, PRA is, right, okay. So PRA is 0 and B is 1. Right, let's go back to utils. So we're storing it in PRA, which is and we're rolling left, so we're rolling that way. Rolling left. Right, so we're rolling left. So we're starting at just working this out. So it rolls left, so that's bit 7 first. So that's bit 7. Right, let's put some rems in here. Bit 7 on this CIA PRA. Bit 6. Maybe I did this the wrong way round. 4. 3. 2. 1. 0. Maybe I've done this the wrong way round. Let's do this the other way. So the way we're going to do that, is instead of rolling left, we're going to be rolling right. So it's going to start off, it's going to be bit 0, bit 1, bit 2, bit 3, bit 4, and so the keyboard matrix index is going to be the bit on DCOO. That'll make it easier to understand then. That will make it easier to understand. Right, so so how we're going to implement this. How we're going to do this. So we've read the keyboard. We've got a 64-bit matrix of the keyboard. So how we're going to do this? I'm going to have to hard code it, I think. Hard code it for now, and then figure out how we can make it programmable later. So we'll hard code it now. So we'll go into controls and we'll create another one called capture keyboard. And we will run keyboard capture. So, now we need a quick way to test to see if a key's been pressed. Oh, we can do it here. Yes, that's correct. You are right. it creates a 64-bit matrix, and each key will be a bit in that matrix, because the C64, the VIC, I think the C16 had it as well, had 64 keys. But what we're going to do is we're going to cheat on this inverter here. We're going to cheat, because what we're going to do is we're going to LDA #0, store it in there. So that's going to initialize that. Then we're going to invert, but here we're going to store it, and then we're going to OR it with key press. And then store it in key press. So if we've got zeros, it will OR 0, which will be 0. But if any one of those bits are set, it will OR it. And so therefore we've pressed a key. So it's a quick indicator to see if a key's been pressed. Seems we're looping through them to invert them anyway, we might as well use that to determine whether we've pressed a key. So our end result, so the first thing we're going to do here is LDA utils dot keyboard capture dot key pressed. There we go. Branch if not equal to 0. And what did we call the other? What did we say this one was? Evaluate joystick. So evaluate keyboard. So evaluate keyboard. So that was there. And if no keys pressed, we just leave. Right, so that means I can do that and get rid of that. I've still got problems that they're not being flagged as 0 page, which is really really worrying. That is. I'll have to look at that. Really weird. Right, anyway, we digress. So first things first, we have got 1, 2, 3. We have got 4 keys on bit 1. We have got 4 keys on bit 1, so we can just look at bit 1. So LDA that dot keyboard matrix +1, because the first one will be bit 0, so bit 1. So that's bit 1, and so let's see. So let's see, W is up, A is left, S is down, and fire. Okay, so we can do the first 3. So W, so and it with 1, 2, 3, 4, 5, 6. So that's bit 1. Branch if equal to 0. And basic, we'll copy all this lot. We'll copy everything. We'll copy all this and then we'll just rename it to whatever we want. Right. So branch if equal try key down. So we'll set everything to be key. Key, key, key. I probably missed a few, but we'll get to them. And one more. So grab that, put that there. Right, let's work our way through this. In fact, I could put the code in for the shield, couldn't I? Anyway, so, oops. So, that's W. So, W is going up. So, we're doing the same function here. Now, I'm now thinking maybe we should pull these out. I'm thinking we should pull these out. Make shit go up. So this one is going to go to exit. And we'll get rid of that as well for the moment. Right, make shit go up. Right, so we'll do down as well. Get rid of that. And they should... Oh. Well, doesn't matter now. Got them in code blocks. Can do that. Yeah, you should be alright. Come on. There we go. Right, so going left. And make shit go right. That's go right. Get rid of that. Right, let's change the joystick now. So we don't need to do that. We do JSR make shit go up. JSR make shit go down. make shit go right. Make shit go left. We'll do the fire in a bit, so we'll do the same here. So this is JSR make shit go down. Right, so we're not loading joystick, we're loading those two. And this time we're making the shit go down, which is S. So that's bit 5. 0, 1, 2, 3, 4, 5. Right, JSR make shit. Oops. Make. Yes, I am at the moment. Just concentrating on getting the shit moving. Because with us doing the jet. What? Oh, I was going to say. So this is. Oh no. W is up, isn't it? So that's up. This is down. Right, this is right. So let's grab this lot. So going right is D. D. What is D? Did I write D down? Oh, is that the 2 and 2? Hang on. Bit 2. Bit 2, yeah. D is bit 2 and 2. Right, so D, and we are on byte 2, bit 2, which is there. D. And we are going to go JSR make shit go right. And then left bit 1. Left is S. Bit what? S. Oh, I've done S. AS. Oh, hang on. D. Oh, that's wrong. Oh no, that's right. It's A, isn't it? A, which is bit 2. 2. Right, so JSR makes ship go left. We will run that out for the moment. No, well, what's fire? We'll put it in. Bit 1 and 7. So that's there. Which is space. Just won't have anything. Don't get it. Have it do anything yet. And we won't. And oh no. Right, fire, we had left shift, which is bit 7. Which is 1, bit 7, and space is +7, and that is bit 4. So 7, 6, 5, 0, 1, 2, 3, 4. That's there, isn't it? 0, 1, 2, 3, 4, 5, no. 0, 1, 2, 3, 4. Yeah, that's in the right place. Right. Will that work? Will that work? So we'll try the keyboard first, and then we'll try the joystick first to make sure it's still working, and then we'll try the keyboard. Right, so that's the joystick. So what we've changed is not affecting the ship. Right, so I'll put the ship back in the middle of the screen. I'll try my best. There we go. Right, D. Press D. No. A. No. Ooh. Right then. Let's find out what's going on. I need to find out where the byte matrix is. mash the keyboard frantically. No, no, no. We're going to do this proper like. Right. So the keyboard matrix is at D 3D 31. 3D 31. Right. Let's see what's going off at that location. So going to the debugger. Go 3D 3 1. There we go. So this is our keyboard here. Yeah. And I'll just make sure that's right. So 60 is at 0 and then 1. Right, okay. So we're all right. So they're all at 0, look, and then that's our key pressed there. So let's press a key, A. There we go. Oh, that's in the wrong place. That's at the end. Right. Maybe I got my maths wrong. Got my maths wrong, and we don't do we'll do a roll instead. Let's try that.
Hello, John here. Thank you for following. Hope you enjoy the stream.
Oh, thank you for following. Ooh, Untruly Denton. Untruly Denton. Got to make sure I spell that right. Welcome. Welcome. Right. So let's do it again. Right. Go to 3D31. There we go. So that's our key press value there. Right, let's see. A. Oh, look at that. D. Okay. W. S. Right, so if I press... So that's S. So if I press W and D at the same time, we should go diagonally. Okay. A and S diagonally down. Nice. Nice, 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 nice. Right, let's run this properly. So, D, A, D, W, S, W and D, A and S. W. Oh, look at that. Right. Okay. I don't know how you can use I don't know how you can use these controls. I don't know how you can use these controls. It drive me up the drive me up the wall. But we've got the keyboard working now. So now we've got the joystick working. Yeah. Or keyboard. It's what all the kids are using, yeah. But so now what we need to do now is we need to have some constants for, like we've got with the joystick. We need some constants to allow us to well, yeah, we can turn the shield on because that's always going to be space. So what we'll do is how we're going to turn it off though. How are we going to turn it off? We'll see if it turns on first. Ooh, that was not the right. Oh, and that's not the right one either. Yeah, time will turn it off. But we haven't got the timer in there. But we'll see if the keyboard comes. We'll see if we activate the shield. So let's move it. And then activate shields. There we go. There we go. God, the shields don't half takes. Look at all that CPU taken up for the shields. Wow. So we'll have the we'll have a timer that will do that, but we'll not code that in. But what we need to do is I mean, we can make it toggle. It's just that it won't be in the gameplay, yeah? It won't be in the gameplay. Yeah, we'll look at the shields. Try and optimize the way it's done. Now, so constants. We need to make constants out of this little lot, right? And what I mean by this is these here. These here. We got to make these constants, yeah. So how we're gonna do that? So where's the joystick? We'll try and put them together. The joystick's not in here, I don't think. They're not the joystick. So that means it's in there. There we go. Right. So we need to put it. We'll need to put it in here. So we'll stick this in. And I know it'll work on that as well. So, so key up index. Right. So key up index. So this is up, is going to be that value there. Oh, we can't use a constant, it's going to have to be a label because it's a location. Key down index is the same. What's the next one? Left. No, right. Key right index is the same. Key left index is not. That's +2. Oh no, hang on. Up, down, right is +2, 1. Left is 1. Fire is 1. And space, shield is 7. Right, so then we can have some constants in here. So key up mask. So the key up mask is 1, 2, 3, 4, 5, 6. That. Down is that. Right is that. Is that. Left is that. Fire is that. And shields is that. Right, let's put them in. Because remember that we're going to have the one source code that will be able to assemble for both, for all the for the 64, for the VIC, for the C16. So we need to be able to make these controls be definable. Yeah. So key index up, key index down. Now, what are you complaining about? You're in constants. Have I not got constant? Yeah, I've got constant. Oh, machine constant. No, they're there as well. Yeah, machine constants. They're there as well. You should not be moaning. Right, key index down. Whoops. Key index right. Labels. Yeah, I think it's just moaning. Left. So this is left. We'll see if it errors when I assemble it. That's fire, and then shield. Right then. Let's see if it moans. It didn't moan. So, using the keyboards, do we still have control? Oh yes. Oh yes. Oh yes. Oh. Screwed up on the shield. So, let's see. The shield was space. And it's 7 and 4. Have I got the wrong one in then? Oh, that's a lot of. That was a bit of a misfire, wasn't it? That's better. Right, let's try that again. Come on. There we go. There we go. Right. Because when it comes to for the keyboard, we're gonna have another one here called you know, and probably another one. Oh, and the extension's thrown a fit. Right, because we've got when we come to doing the these, the PET, the VIC, and the C16, we'll redefine all these constants and labels to match the specific machine, and so it means that when we assemble it for the different machine types, at least the labels and the keyboard matrix should still work for all the machine types. We haven't coded it for the PET or the C16 yet, because we need to work out that exactly all the same methods, just different layout. Yeah, so we'll run the same routine. It's just that depending on what we put as the directives, they'll get they will get redefined. For the C16 there'll be different numbers, for the VIC will be different numbers, but it will still use the same routine, like we've done with the joystick, where we rejigged all the joystick to make it come out. I mean, even for the PET lot, the joystick was actually the extended keyboard, yeah. But we rejigged, so the VIC joystick routine, the joystick port, is configured completely different than the C64. But what we did was we took the VIC joystick routine and then reconstituted it to make it spit out a result like it was on the C64. That's what all this code does, is just to be able to map it like a C64. And the C16 and all that, I think the 16 is the same. Oh no, there it is. There's the C16 64. But we did the same thing there, because that's mapped differently. We had to do a bit of tweaking to make it spit out a 64 compatible routine. So we'll do the same thing for the keyboard. We'll work out from the 64-bit matrix what all the keys are, but we need to make sure that for the PET we need to understand what the keyboard layout is, and for the C16 we're going to have to understand what the keyboard layout is so we can work it out. So I've achieved what I wanted to do today, which was to get the ship moving about the screen. Yeah, so we've got the ship moving about the screen. So the next thing, in the next stream, we're going to try and implement the the bad guy array, you know, the object array, and try and make it more optimized, because it was done, in my opinion, not as smart as it could have been, and I think we can make it a lot smarter in how we do it. But I want to be able to, what I want to do is get the bullets on the screen first. So when we're pressing the fire button, it's shooting bullets, yeah, and then we can start expanding the bad guy array to make it put all the different bad guys on the screen, get them drawn, get the movements right, and then we can work on the mechanics of how we introduce them to the screen and stuff like that. But that's that's a long way away. Yeah? We're just doing small steps. But what I want to be able to do is to put it in VIC-20 mode, and it should still work. And so that might be a task to do on the next stream, is to get the VIC-20 profile up and running, so we can see if we can run it as both the VIC and the C64 on the same code. But that'll be on the next stream. Well, that's another biggie. an hour up front for the Pi bot, the Twitch bot, and then all this. Right, Okay guys, well thank you very much for joining me. Hope this is getting interesting, because this is how we recode from what we've learned from reverse engineering and try and make it better. Alright, well thank you very much for watching, and I'll see you on the next stream. Take care. Bye. I'd like to thank all the Patreons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.